organic matter in these bond systems. That's due to the uneven pieces, dead plankton, and also the bond shells like that. This gives the poor water quality that increases shrimp stress and also the prices of fish. And also accumulation of thick sludge layers at the pond of the bottom that covers shrimp's natural habitat and restricts their natural behaviors like behavior and creates anoxic zones. And also this nutrient-rich sludge supported some pathogenic microorganisms in made it zone. So farmers have to regularly renew the water and also remove the accumulated sludge between the culture cycles. But this is time communication cost and also is labor intensity. So the probiotic is an eco-friendly approach because can improve water quality and also can suppress pathogens and also enhance productivity of coral shrimp aquaculture. Among these beneficial microorganisms, heterotrophic bacteria that form sediments and the gut system of the shrimps show strong probiotic potential by producing some extracellular enzymes. Those can degrade the accumulated organic waste that leads to bioremediation, and also those can digest some complex nutrients in the feed that will, especially who are in their gut system, can improve the nutrient utilization and growth. So screening of these beneficial microorganisms continuously is very important to vital for sustainable shrimp farming. In this context, Actinomycetes is a group of bacteria giving specific attention. There are the diverse group of heterotrophic bacteria. So gram-positive bacteria shows filamentous growth resembling fungi, and also renowned for producing different bioactive compounds, especially some antimicrobial properties. And also some studies show they have some strains extracellular enzyme production that's supporting biocondition of organic waste in different environments. However, strains associated with shrimp farm ponds and their gut system remain unexplored. So, objective of our studies to evaluate the probiotic potential of Actinomycetes isolated from the gut of the cultured shrimp and the pond of the pond segments with their extracellular enzyme production. So this is our study area. In Mundala, in northeastern province, we obtained samples from two culturing ponds, pond culturing Fenis monodon and pond culturing Fenis economy. We obtained two types of samples. This includes sediment samples and shrimp samples. Sediment samples are obtained from wet sampler, and shrimp samples included two common marine shrimp species, cultured in Sri Lanka, Fenis monodon and Fenis economy. Shrimps were kept feeding approximately 12 hours to clean their gut system, and these shrimps were aseptically dissected to clean their gut system, and both gut samples and sediment samples were subject to retreatments to suppress other bacteria and also Actinomycetes and Richmond states. Then zero diluted samples were plated on specific specific starch casing agar prepared using brackish water, and also cycloheximide fungicide and antibiotic to suppress other fungi and bacteria. The physical parameters of the samples did not vary significantly among size, and the average conformity also show no major difference. And all the isolate displayed typical Actinomycetes characteristics, including the powder colonies with distinct aerial and substrate mycelia. And also the microscopic examinations revealed the filament structure, gram-positive nature, and positive for the catalyst reaction, further confirming their identity as Actinomycetes. Actually, we obtained total 19 Actinomycetes isolate, 14 from sediments and 5 500 samples. This was screened for the extracellular enzyme production, including the protease, amylase, cellulase, lipase. Its isolate was 40 mg selective media. Then enzyme matrix was measured by calculating enzyme index, the ratio of colostones to diameter. This represents the enzymatic index values of all the 19 isolates as shown in the bar chart. There are notable variations in enzyme production amongst isolates, some are without enzyme index also. The results reveal interesting patterns. About 8% of the isolates show significant enzyme activity with A values 2 or higher than at least 2 enzymes. And also, cellular circuit was found in 68 of the isolates with maximum EI 8.2, and amylase and protease circuit was observed in 73% of the isolates, maximum EI 5.1 and 3.8 respectively. And also, lipase circuit was the most prevalent and found in 89% of the isolates. However, the maximum EI was comparatively lower than others. It was 2.7. And also there's an interesting finding that all the derived isolate producing coenzymes showed strong probiotic potential. To conclude our study, that Actinomycetes strains isolated from shrimp farm ponds and their strong extracellular enzymatic activities. These findings highlight their potential role as natural probiotics capable of bioremediation and natural nutrient dilution, special to isolate from the system of the shrimps. And also, I want to thank National Agriculture Department of Development Authority of Sri Lanka for the available support. And thank you all for the kind attention.
Nice presentation, Mr. Malasinha. So now